Due to the high level of accuracy and stability of the CMC test sets, meter testing has become much easier. The use of reference meters is no longer required since the signal source itself becomes the reference. The CMC not only provides the test signals, but also allows for closed-loop testing. For optical meters, Omicron offers a variety of scanning heads to capture the pulses and incorporate them into the test assessment. The meter test module from Test Universe allows for manual or automated testing of energy meters. This video tutorial will guide you through the setup of the test module, including the test object and hardware configuration. For this purpose, we will test an ISKRA energy meter while using the CMC as a reference. We open the test module directly in standalone mode. According to Omicron's Ohm's law, we will enter the general device settings in the device block of the test object. As explained in previous videos, this block contains parameters such as name, manufacturer, and nominal values. We will assume that the meter is located in a 110 kV and 600 amps network. The secondary values are set according to the nominal values of the meter, that is, 400 volts and 5 amps. As we are using a dedicated test module, a new RIO block is also available. The meter block contains the specifications of the meter that are required for conducting the test. As we can see from the first drop-down menu, this module supports different meter functions, including, for instance, the measurement of active, reactive, and apparent power. Depending on the power flow definition, we have to indicate whether exporting should be considered from the point of view of the generator, that is 0 degrees, or from the point of view of the consumer, that is 180 degrees. Set this parameter according to the meter's configuration. When choosing one of the meter functions, it is necessary to specify the energy direction of the test according to our definition. In our particular case, we will check the energy in watt-hours from the generator's point of view. Now, we can choose from importing, exporting, or bidirectional. The power angle of the test will be adjusted depending on this selection. We will choose exporting, so the power angle will be set to 0 degrees by default. The test can be performed with any balanced or unbalanced load for single-phase, 3-wire, and 4-wire meters. Since the meter under test presents inputs for 3 phases plus neutral, we select the 4-wire option. The pulse type option can be set to active high or active low, which must match the meter under test in order to measure the pulse count accurately. Our meter under test counts on active high pulses, which is on the rising edge of the measured pulse. The CT and PT ratios are taken from the RIO block device. If it is necessary, go back to this block to modify these values. The meter constant is critical for the conversion of pulses into a measurable quantity of power. The meter constant can be entered into one of these fields, either as a primary or secondary value. The remaining 3 fields are automatically populated according to the CT and PT ratios. The setting time allows the meter to establish a stable operating state. This way, the meter is able to perform a reliable and stable measurement. Search for this setting on the respective datasheet. For this test, we will keep the default value of 5 seconds. For the evaluation of the test results, the value for the tolerance has to be specified. This is done in the class field. In our example, the value will be set to 0.5. If you are testing old electromechanical meters, set the correlation between the rotation of the disc and the number of pulses. This factor and the meter constant are required in order to calculate the total amount of energy. Once all of the information has been input, we can confirm the dialog. The next step in Omicron's Ohm's law is the hardware configuration. We will choose to have 3 voltage outputs and 3 current outputs from the general configuration of the CMC test set. This particular meter includes binary outputs in addition to LEDs. This means that there is no need to use an optical scanning head since we can route one of the relay's outputs to one of the CMC's binary inputs. Therefore, we configured the first input to be a counter and we confirmed the dialog. Check out the next video tutorial to learn how to configure the meter test module.